Hello and welcome to today's video. Now that we've finished section 4.7, we're gonna do a little bit of 4.8 just for today. And 4.8 is applications of graphs of trig functions. Applications is code for word problems. So if you had the opportunity to print the worksheet, that would make note-taking a little easier for you, and you definitely want a calculator to go through today's lesson. If you don't have your own graphing calculator, you can access the one through the PARC website, the NJSLA website. The instructions for accessing that are still in Google Classroom under General Info and Resources. So we're going to go through a few problems today, and here's our first one. So what we have is we have a model for sales, an equation for sales of a seasonal product, where T is time in months, and the sales are in thousands of units, and T equals 1 corresponds to January. So this is a trig function. This is a cosine graph. There's been some sort of horizontal stretch or shrink, a horizontal shift. This causes a vertical stretch. This causes a reflection. And then this causes a vertical shift up 52. So this is a cosine graph. It's not one we would graph by hand because it's pretty complicated, but it's just a cosine graph. So what we want to do to go about trying to address this question of determining the month in which sales will peak is we want to graph this function. So since this is periodic, let's find the period first. The period for sine or cosine is 2 pi over absolute value of b. That's the period for sine, cosine, cosecant, and secant. If we were talking about tangent or cotangent, it would just be pi over b. So for this problem, the b value is pi over 6. So instead of dividing 2 pi by pi over 6, we're going to do 2 pi times 6 over pi. And the period comes out to 12. And that should actually make perfect sense because we're talking about the sales of a seasonal product where T is the time in months. So every 12 months, we have a full year. So every year, this graph is going to repeat. So let's go ahead, now that we determined the period of the function, let's go ahead and try to make the graph. So you want to input 52 minus 28 cosine pi. You're not going to put T, you're going to put X instead, and the rest of the equation. And if you go to Zoom Standard, so Zoom 6 for Zoom Standard, that's usually where we start. And that's a good place to start right now, because one thing we want to do today is figure out how to get a good viewing window. So to get a good viewing window, we want to determine the period of the function if it's a periodic function like we just did, get the equation in the calculator, and let's adjust the x min, x max to show one full period. So in our window, one full period would go from 0 to 12 for one full year. Or since we're calling January 1, we might want to go from 1 to 13. And if it seems weird to call January 1 instead of starting at 0, it's actually to help you, because if you think about it, we know the numbers for the months. Like right now we're in month 5, because when we write the date, we write 5/12. And month 5 is May. Month 6 is June. Month 7 will be July, and so on. And that only works if 1 is January. So if we were to start this at 0, if we were to use 0 for January, then everything would be thrown off. Because if 0 were January, then 5 would actually be, if 0 were January, then 4 would be May, and 5 would be June, and 6 would be July. And as you saw, I just stumbled on that because it's weird. We're used to 5 being May and 6 being June and so on. So that's why they have you do T equals 1 is January. So let's go 1 to 13. And then it says, go ahead and hit graph. And often you won't see anything at this stage because the graph probably is not going to be in this viewing window. So if we hit the trace button, this calculator will give us the coordinate of a point on the graph. So if we look, we can see that at 7, it'll always give you the midpoint. So if we're going from 1 to 13, it's going to give you the middle. So it's 7, and it's up there at 79. So right now my y max only goes to 10. That's why I can't see this. So I have to go up at least to 80. So for the y max, let's go up at least to 80. That's probably not going to be enough, by the way, because usually you want a little extra space there. So I went up to at least 80, and that's a pretty good picture of what I have. And what we can do is we can actually go up higher. You can take it to 90 or take it to 100, and you might be more pleased with that viewing window. Okay, now this is what our sales looks like. So this is the time in months. So I'm at 1 is January, 2 is February, 3 is March, and so on. And this is my sales in thousands of units. And this is 1 year of sales. Before we finish this problem, what I'd like to do is extend this out to 36 months. So from 1 to 37 is 36 months. So that'd be 3 years. Just to show you what's going on in real life with this. So the y-axis is the sales, the x-axis is time. So what happens is in the first year, you have some low sales, and then you hit a peak. And then you have low sales again. That's the first year. The second year, that repeats. The third year, that repeats. That's because this is a seasonal product. And if you look, in January, you have very low sales. In February, you have low sales. But when you get into the summer months, like June, month 7, July, month 8, August, you have high sales. And that's going to happen every year. So in the winter, low sales for this particular model. In the summer, high sales. Next winter is low sales. Next summer is high sales. So that's the idea of a seasonal product. So if you think about something you might be selling in the summer, that's what we're talking about. So maybe you're selling swimsuits, or you're selling pool supplies or barbecue accessories, something that people would use more in the summer, but they really wouldn't be purchasing much in the winter. So that's what's going on in the problem. Let's get back to the task at hand. So I'm going to go back to looking at just the 1 year. So I'm going to go from 1 to 13 on the x-axis, and I went up to 100 on the y-axis. And our job is to determine the month in which the sales peak. So by the way, I'm just making a quick sketch because anytime we have a graph on our calculator, we want to sketch on our paper. So if we do second trace maximum, just make sure you're to the left of the max and hit enter. Make sure you're to the right of the max and hit enter. You don't have to go to exactly where I went. Just make sure you're left and right. Get as close as you can to take your guess, hit enter. And you can see that that point is about 7.380. So to answer the question, the month in which the sales will peak is month 7, which is better known to us as July. And if I were to ask you what the sales are at that peak, what would the sales be at the maximum or at the peak of sales? That's 80,000 units. So if you have 80,000 units, you could write it like that, or you could put 80, and then you could put 80,000. So the way you read it would just be the way you write it as a number. So if you put 80 in the Edpuzzle, don't feel bad. It's an easy thing to miss. So you always want to go back and make sure you're paying attention to what your units are. So because we were in thousands of units for that one. So that's why it should be 80,000, not 80. All right. So that's the first one. Let's go to number 2. Number 2 deals with a sine function this time instead of cosine. And it's a function that models the temperature someplace on some day. All right, so what we can do here is you can clear this out, but if you notice, I'm all set up for all my equations. So just something that you may not be aware of in the calculator is if you're ever doing some work and you don't want to erase the equation, you can deselect it. See how the equal sign is no longer highlighted? So if the equal sign is highlighted, it'll graph that function. So if I were to highlight both of those, it'll graph the function from number 1 and the function from number 2 when I hit graph. But I don't actually want both of those. So what I can do, like let's say I want to go back to this later, I can deselect that. So hit enter, and it's only going to graph the one that is selected, only the one with the darkened equal sign. So this comes in kind of handy because if you think about those of you in AP Physics, when you take the test, if you have to graph something and then graph something else, but you might want to go back to that other graph later, you don't have to erase it. You can actually keep it there. I know I just erased it, but you can keep it there so that you can just turn it off and go back to it later if you want. So kind of handy to be aware of. So let's get to number 2 here. We have the temperature in degrees Fahrenheit. This is the equation. And x equals 0 corresponds to midnight. And I did not put that x is at hours. I should have typed that in there. Okay, so let's go back to Zoom Standard because I'd like us to practice getting a good viewing window. So using the steps from earlier, go ahead and find the period of the function. The period of the function should end up being 24 because when you do pi divided by pi over 12, you're going to end up with 24, which should make sense because 24 is how many hours in a day. And then go ahead and follow these steps and try to get a good viewing window. From Zoom Standard, when I didn't see anything, I first changed my X-min to 0, my X-max to 24, because we found out that the period was 24. And then I didn't see anything when I graphed. So if you hit trace, you'll find a point on the graph. There's always going to be the midpoint of whatever your window is. So at 12, we're up at 49. So you might have first tried like 50 for your Y max, or you could try 60, or you could try 70, you could try 100. So you're not going to necessarily get a great window on their first try. So you might have to adjust your Y max again. And in this case, I do. So 50 wasn't quite enough. So that's why, let me go up to 80. Maybe you did 75. Maybe you did 60. And this is what our graph looks like. So for my graph, it looks like this. I'm going to show my window. I went up to 80. Maybe you went up to 60 or 65. And just to kind of point out, what's going to happen is if we were to look at this graph over 48 hours, it's cyclic. It's going to repeat. Now, temperatures in the day don't repeat exactly like this, but I think you can see how it does pretty fairly well model what happens in real life. Because what happens in real life is overnight you have low temperatures, and then generally speaking during the day the temperatures rise, hit a peak in the early afternoon, and then overnight in the evening they start to drop, and overnight they hit their low, and then it kind of repeats. It doesn't go exactly like that every single day, but that's a fairly good model for most days when it comes to our temperatures. Another thing to point out about this graph is you can actually kind of predict your window ahead of time if you look at these values right here, because this is your vertical stretch of sine and this is your vertical shift of sine. Since this is your vertical shift, that's where the midline is going to be. So if I go in and put y equals 43, that's the midline of the graph, and all your maxes are 11 higher than that. So 54, 43 plus 11 is going to be where all your maxes are. And then 43 minus 11 is going to be where the height of all your mins, which is 32. So just to kind of point out, because you guys know so much about your sine and cosine graphs, you actually may be able to predict what a good window would be because you understand what the vertical shift does to the graph and what the vertical stretch does to the graph. Okay, so that was some extra info just to get you thinking. And what we want to do now is we want to determine the hours in which the temperature will be 48 degrees or higher. So we're not looking for just a max or a min this time. We want to know when we're 48 degrees or higher. So there's a few ways you might be thinking of doing this. One way is to look at the table and find out when you hit 48. It's not a super great accurate way because certainly we're above 48 for all of these values, but we don't know exactly when we go above 48. Does it happen at 11.2 or 11.5? We don't know. So using the table is not the best way. Another idea people often have is hitting trace and just kind of tracing the graph and seeing when you hit 48. Because here we're at 46 point something, 47 point something, and now we've surpassed 48. It's just not a highly accurate way. If you want to know when you reach a certain Y value, the best way, in my opinion, that is very accurate is to graph a horizontal line at that Y value that you're interested in. So if I put in y equals 48, what we can see is this is the entire time period when we are 48 degrees or above. And if we hit second trace intersect, the calculator, if we go as close as we can to the point of intersection, hit enter again, because now I'm on my other graph, and then take my guess, we can get a very accurate estimate for when we get above 48. So this point here is 11.4, right around 11.4 if I round, comma 48. So that's when we hit 48 degrees. And then we're going to be above 48 degrees all the way till here. So do second trace intersect again. And this is an important calculator skill for next year in calculus, by the way. Believe it or not. So go ahead and get over here close to this point of intersection. And right now I'm on the sine graph and I hit enter. Then it puts me on the horizontal line. So I hit enter again, and then I take my guess by hitting enter again. And this is the most accurate way. This is the way to get a most accurate answer, the most precise answer you're going to get from the calculator. So better than just looking at the table and estimating or just hitting trace, putting in that horizontal line at y equals 48 is the most accurate way to do this. So to answer the question we have, determine the hours in which the temperature will be 48 degrees or higher during hour 11. So in the 11 a.m. hour, all the way up until the 19th hour, during the 19th hour. So if we think about military time, if we subtract a 12 from that, then we'll get 7.7, so that's in the 7 p.m. hour. And this is sufficient for the answer for this because it says determine the hours in which the temperature is going to be 48 degrees or higher. I didn't say determine exactly when. If I ask you to determine exactly when, it actually becomes more complicated because 11.4, you'd have to convert that 0.4 hours into minutes. So often these types of questions just ask you in which hour or in which month and so on. So this is sufficient. And let's go on to one more problem. And here we have Gina has a bagel shop, and this is her profit. And this is not a sine graph. If you notice, there's a 3t here. So in addition to the variable right here, there's a 3t here. So that's actually going to impact the graph. This is not going to be just a regular sine graph that is periodic. So let's take a look. We have t equals 1 corresponds to start of January. P is the profit in hundreds of dollars. We're going to graph the function over 1 year. Okay, so if t is in months, I'm going to graph over 1 year. We're going to do this equation, and we're going to go over 1 year. And I'm actually just going to leave the y values the way they are, if that's all right with you. Oh, you know what? Let me make it 1 to 13, since t equals 1 is January. And this will not be a regular sine graph. I have to select the equation to make sure it actually graphs it. So it looks similar to a sine graph, but it's not periodic because it's not an exact repeat. Because if it were an exact repeat, like you'd have the same exact piece here and then the same exact piece here and over again. And that's not what we have. This looks like a sine graph, but it is going up on an angle. And actually, this is pretty interesting. If you go ahead and graph, you know, that 3x, that linear term there, if I go ahead and graph y equals 3x, what you basically have is a sine graph that uses y equals 3x as kind of a midline. I think that's kind of neat. And here's what this represents in this particular problem. So this is the time in months, and this is Gina's profit from her bagel shop. So what happens initially she's actually not making a profit. She's spending more than she's making. And that happens often in real life, especially in the beginning. And then what happens is right around here, she starts making a profit because she's selling more bagels, making more money. And then at some point, it dips down again. And what might be happening there is maybe she has to buy more machines because she's making so many bagels every day now that she needs a second machine. So she has to spend that money, which means her profit will be less until she's selling more and more bagels. And then maybe here she is doing so well that she's outgrown her space, and maybe she has to move to a bigger storefront to rent. So then as her costs increase, even though she's selling a lot of bagels now, she's gonna have to pay more for her rent, and then she can start to make more money again as time goes on. So if I extend this over to from time equals 1 to 25, so for 24 months to see 2 years, maybe this is what her profit looks like. Okay, so back to 1 year, what we want to do is determine the month in which the shop first began to make money. So here we have negative profit. She's spending more than she's making. Right there is what we want to find. So let's get a little sketch. Okay, just a rough sketch. And we went out for 1 year. This was t equals 1. I still go up to 80 on mine. Maybe you're at 70 or 60. And in order to find this value right there, we're going to do second trace. It's not intersect we want. Second trace 0. So what we want to do is go to the left and the right of the x-intercept there. And if it bothers you that you can't see the x-intercept, you can always go in and decrease that y min. And that'll allow you to see down lower, and that'll give you more space for when you try to find that x-intercept. So let me go down just a little lower there. I'm not going to bring this down too. So I want you to be able to see that little piece there. Okay. So as I go to find my x-intercept, I want to go to the left of the x-intercept, to the right, and take my guess. And what I get there is about 2.010. So it's in month 2. So if t equals 1 is January, then we're talking February, and it's right at the beginning of February because the decimal part is so small. So very quickly, just after just 1 month, she's already making a profit. And by the way, if you did not change your window, you actually can still do this even if you can't see the portion of the graph that is below the x-axis. When you do second trace 0, as you make your way over here, even though you're not going to be able to see the cursor anymore, check out your y values. You should know when you cross the x-axis because your y values will change from positive to negative. So now you know for sure you're below the x-axis. So even though you can't see the cursor, you can still do this. And once you get above, you're to the right of it, and then take your guess. So if it doesn't bother you, you don't have to change the window, but it might be easier just to change the window because it only takes a moment longer, and you can see what time. All right, thanks for watching.